Okay, so in this tutorial we're going to go over a determination of empirical formula from combustion analysis. And the problem that was given in the homework is shown on the screen. And essentially in this problem, this is 55B by the way, essentially in the problem what they want you to do is to figure out what the empirical formula of menthol is, and then also what is its molecular formula. So to begin, this is a typical type of combustion analysis problem, and basically in a combustion analysis a sample is placed into a furnace and some oxygen is pumped in to allow it to burn, and there are chambers after the furnace in which a certain byproducts of the combustion are collected, most typically H2O and carbon dioxide. So in this particular problem, we're told that menthol, 0.1005 grams of menthol are burned, and we get a certain amount of H2O, 0.1159 grams, and a certain amount of carbon dioxide, 0.2829 grams. So they want us to figure out what the empirical formula is. Now, to begin, I know the formula is going to look something like CXHYOZ. And the reason I know that is because they're telling us that it contains carbon, hydrogen, and oxygen. So what I simply need to do is to figure out what those subscripts are, what X, Y, and Z are. And if I can do that, I can figure out exactly what the empirical formula is. So we take a look at the information that we're given, and we're told that we get 0.2829 grams of carbon dioxide. And what I want to do with that information is I want to figure out how many moles of carbon are present in that sample. And of course, I also want to figure out how many grams of carbon are produced. And to do that, I'm simply going to set up my dimensional analysis. And this first step here, multiplying by 1 mole of carbon dioxide per 44.01 grams of carbon dioxide, converts the grams of carbon dioxide to moles of carbon dioxide. Next mole ratio I want to use here is the mole ratio of carbon to carbon dioxide. I see that in the formula, for every 1 mole of carbon dioxide, I have 1 mole of carbon. So I'm going to carry out that calculation, and I'm going to write down how many moles of carbon dioxide are being produced here. I'm not going to stop here. I want to figure out exactly how many grams of carbon are produced. Now to do that, I'm going to multiply by the molar mass of carbon, which is 12.01, and I get 0.07720 grams of carbon. I'm going to carry out the same procedure to figure out how many moles of hydrogen and how many grams of hydrogen are produced in my sample of water produced. So to do that, I take my sample of water that was produced and I multiply that by 1 mole of H2O per 18.02 grams of H2O. That first step gives us moles of water. The next step I want to do is I want to multiply by the mole ratio of hydrogen to H2O. And so in the formula, I can see that for every 1 mole of H2O, I have 2 moles of hydrogen. I want to write down that value as well. And I see that I get 0.0128 moles of hydrogen. I want to take this a bit further and figure out how many grams of hydrogen are produced, and to do that I'm going to multiply this by the molar mass of hydrogen, which is 0.0079 grams per 1 mole, and I get 0.01297 grams of hydrogen. The reason that I went as far as figuring out the mass of carbon and hydrogen is because I need to figure out how many grams of oxygen were originally in the sample of menthol. I do know what the total mass of menthol was to begin with. It's 0.1005 grams of menthol. If I subtract the mass of carbon and the mass of hydrogen from that, I can figure out the mass of oxygen. And that's precisely what I did here. And by subtracting, I see that I get 0.01033 grams of oxygen. I want to take this mass and convert that to moles. And to do that, I multiply by 1 mole per the molar mass of oxygen, and I get 0.006456 moles of oxygen. So let's recap what we know so far. We know moles of carbon, we know moles of hydrogen, and we know moles of oxygen. To figure out the empirical formula, what we want to do is divide, in this case, by the lowest mole value, that being the number of moles of oxygen, And when we do that, we see that we get a mole ratio of 10 to 20 to 1 carbon to hydrogen to oxygen. Now, if I carry out the calculation to figure out exactly what the empirical formula mass is, I see that it's 156.26 AMU. And so I go back to the problem, and I see that the molar mass of menthol is 156, which is basically the same as the empirical formula mass. And so what that tells me is that C10H20O is both the empirical and the molecular formula.